Welcome to this lecture video. In this video, we will see about topological sort. Topological sort is a linear ordering of vertices in a directed acyclic graph such that for every directed edge u, v, vertex u comes before vertex v in the ordering. While seeing the properties of topological sort, it is must that topological sort is only possible if the graph is a directed acyclic graph. And a topological sort is not necessarily unique. It may have multiple ordering might exist for a graph. Number of sortings may vary independent to the multiple subgraphs. There can be different valid sort depending on the order of processing vertices with no income edges. Okay. Now we will see how to find the topological sort for the given example. This is the example program we have to sort. Now, the first and foremost step I have to follow is finding the adjacency matrix. We want to find the adjacency matrix for the V1, V2, V3, V4, V5, V6, V7. Similarly, V1, V2, V3, 4, 5, 6, 7. Okay, we know to find the adjacency matrix. Adjacency matrix is nothing but we want to see whether there is a path exists between V1 to V1. There is no path exists between V1 to V1, so we are marking it as 0. V1 to V2. Yes, there is a path exists between V1 to V2, and there is a path exists between V1 to V3. Yes. V1 to V4. Yes. V1 to V5 there is no path. V6 there is no path, and V7 there is no path. Similarly, we have to find out all the path present between the vertices. We can see V2 to V2, V1 0, V2 we have only path from V2 we have only path to V4 and V4 and V5. Remaining all we have to mark it as 0. Okay, and from V3 we have only path to V6. Remaining all we have to mark it as 0. From V4 we have path to V3. We have a path to V3, V6 and V7. Remaining all we have to mark it as 0. From V5 we have path to V4 and V7. Remaining all we have to mark it as 0. And from 6 there is no outgoing path, so we are marking it as there is no outgoing. Okay. From V7 we have only path towards V6. Okay, now we have completed finding the adjacency matrix. Next step is that we should calculate the in degree of V1, V2, V3. In degree of V1 is equal to, we have to see whether in V1 have any incoming edges to V1. There is no incoming edges, so it is 0. V2 we have one incoming edges. V3 we have two incoming edges. 4 we have 3 incoming edges. 5 we have 1. 6 we have 3, and 7 we have 2. Okay, this is the second step we have to do in the topological sort. Now next step is we have to find out, we'll fill this v1, v2, v3, v4, v5, v6, v7, and we have to calculate NQ and DQ order. Q and DQ order. Okay. We have to see which vertex have 0 in degree. It is nothing but V1, so we will mark it as 0, 1, 2, 3, 1, 3, 2. Okay, now we want to NQ the vertex which has 0 in degree, which is nothing but V1, and we are DQing that same V1 from the NQ. Okay, next, if we remove this V1 from the topological sort, again calculate the in degree for all the vertices, which is nothing but see here in this table which vertices have a degree in degree from V2. It is nothing but 4 and 5. So minus, we want to check V1, from V1, which are all the vertices which have in degree, which is nothing but V2, V3 and V4. So we want to minus a value from V2. V2 is nothing but, if we minus V2, 1 from 0, 1, 2, 1, 3, 1, 3, 2. Okay, now see which vertices have 0 in degree, which is nothing but V2. Now we will NQ V2 and DQ V2. Next, see which vertices have 0 in this in degree calculation. We have taken V2. If V2 is removed from this graph, see, then again you have to calculate the in degree. See which are all the vertices that is having in degree from V2, which is nothing but 4 and 5. You have to minus a value from 4 and 5, which is 1, 0. Hope you understand this concept. Remaining all you have to put as such. Remaining all value you have to put as such. Now calculate this is V7. Okay, now see which degree has 0 in degree if V2 is removed, which is nothing but 5. Now we are going to NQ V5 and DQ V5. Okay, now calculate the in degree if V5 is removed from the graph. Now we have to calculate the in degree if V5 is removed. We can see that only V4 and V7 have in degree from V5. So we are supposed to minus a value from V4 and V7. Remaining values you can write as such. Okay, now see, we can see that V4 has 0, so we are NQing and DQing that V4. And now we have to remove this V4 and calculate the integrity from integrity if V4 is removed. We can see there is an integrity from V4 to V3, V6 and V7. V3 we have to minus 1 value, V6 we have to minus 1 value, and V7 we have to minus 1 value. Okay, remaining you can write as such: 0 0 0 0. Okay, here we can see that V3 has 0 and V7 has 0. First we can say we can take V3 and we can NQ and DQ V3. Okay, again if we fill the value as such, we can see that if we remove one more value, we have to, one more step is there. What is that is, if we remove V3 from this graph, we have to calculate the integrity. From V3 we have only one integrity to, we have only one out degree, that is to V6. If we remove the minus that value, then this will be the answer. Here we need to NQ V7 and DQ V7. If we DQ V7, again there is only 1 degree from V1, sorry, 1 out degree from V6, which is V7, which is to V6, so we will be minusing that value. At last we are going to NQ and DQ it. This is this process we want to follow in topological sort. Hope you understand this video. Thank you for watching.